Hi class. In this video we're going to look at a problem that's very similar to P8-23 in your homework. So again, I'm going to use the ebook, so mine's going to look a little bit different than yours, but hopefully that you can make the transition from what I've got to work with what you've got to work with. So this problem says Lou Barlow is a division manager for Sage Company, has an opportunity to manufacture and sell one of two new products for a 5-year period. His annual pay raises are determined by his division's return on investment, which has exceeded 20% each of the last 3 years. He has computed the cost and revenue estimates for each product as follows. We have some information on product A and B, and it says the company's discount rate is 18%. Again, we have the links to a couple of charts that we're going to use. So this one is the present value of $1 chart. I'm using links because I have the ebook. Your charts, I think, are probably in the back of the book or the end of the chapter. The other chart that we have is the present value of an annuity of $1 in arrears. So we will also be using this chart. So the tricky thing with these problems is always to figure out which chart to use. So hopefully this demo will help you. So in this problem, we have a series of requirements to do, and so let me get over here to the right problem. So requirement 1 says calculate the payback period for each product. So in other words, we're calculating how long before our initial investment pays for itself. So to do that, I've set up a little table here, a column for product A and a column for product B. So we're going to look at our sales and take out the cash expenses that we're going to have and look at our cash flows, and then we'll get to step 2 is actually calculating the payback period. So I'm sorry, I'm going to have to kind of, well, maybe I can minimize here and do this so we can see them both at the same time. All right, so we've got in our chart of given information, let's see, we've got sales revenue of $310,000 for product A and $410,000 for product B. And then back over here to our chart, we've got variable expenses of $144,000 and $194,000. And those really should be negative, so let me show those as cash outflows. And out-of-pocket expenses, looks like $76,000 and $56,000. All right, so at that point, after we get all that information that's given and filled in our little chart, then we can calculate our total cash flows by some icon uncovered. So it gives us cash flows of $90,000 and $160,000. So we need to calculate those before we actually get to step 2 of the problem, which is to calculate the payback period. So we needed to put in the investment required. Let me move this back over a little bit. So it looks like product A has an investment of $260,000 and product B, excuse me, product B is $470,000. Then we are going to put in our annual net cash inflow, and that is the amount that we calculated up here. So $90,000 for A and $160,000 for B. So then we can calculate our payback period. So basically what we're trying to figure out is if we're going to get, well, let's look at product A. If we're going to get $90,000 a year, how many years is it going to take us to pay off our investment, which is $260,000? So to do that, we're going to take the initial investment and divide it by the annual cash flow. and I didn't round these, probably should have, but so I have lots of decimals. So it looks like 2.89 years, and those are actually years. Let me put that out here. So 2.89 years, let me clean that up a little bit, and 2.94 years, rounded to 2 places. So it's going to take almost 3 years in either case for us to make back or to recover our initial investment. It's actually going to take us a little bit longer for product B than product A, with the investment that was required being higher. Also, the annual net cash inflow was higher, but not high enough to cause that one to have a payback period that was quicker. All right, so let's look at requirement 2. Requirement 2 says calculate the net present value for each product. And this chart looks very much like the example I did. I think that was the first step we did in requirement 1 of P8-17. So this should be familiar with to you. We're just going to actually have to calculate 2 of these because we have to do one for product A, and then we're going to do one for product B. But the process is going to be the same. So here's our product A information. So at this point, which is today or now, we have a cost to purchase the equipment. So that's a cash outflow of $260,000. At this particular point in time, there's no other cash flow associated with that purchase. So we can stop right there. For purchasing equipment, we don't have to worry about that for years 1 through 5. But we're going to drop down a line to sales. And the sales amount comes from our chart was $310,000. And our variable expenses were $144,000. Oops. And our out-of-pocket costs were $76,000. And I'm actually going to copy all this over because the estimates that were given were the same. It doesn't say they're any different for years 1 through 5, so they're all the same. So you can just copy that over. So your cash flows are the sum of those columns. So we've got $90,000 a year for 5 years. And then we get down here to the tricky part. We have to find the discount factor. So the discount factor is what we're going to apply to each of these cash flows to bring those future dollars back into the present value of those dollars. So we should expect that $90,000 in a year is not going to be worth what that amount would be worth now. Think about that as if you win the lottery. If you get paid something in the future, you can usually choose to get paid out in the future, or you can have a lump sum payment immediately. And if you choose to get paid in the future, it's a different amount than what you would get if you get paid that today. It's actually, you're going to get less if you're paid today. And that's because of the time value of money. So we can expect each of these amounts to have a lower present value than $90,000 because we're discounting them back to the present day, so they lose some value. This one, the $260,000 investment, is actually happening in the present, so the present value of that one is $260,000. So you can put this in if you want, or you don't have to, but the discount factor of that is 1. It's worth, the purchase of the equipment is worth whatever we paid for it times 1, which is whatever we paid for it. So the present value of that is a cash outflow of $260,000. And I did that by multiplying the discount factor, and actually this should be down here. The total cash flow for the period of now is negative $260,000 times 1 is $260,000. So for year 1, I'm going to bounce back over here, and I'm sorry for the toggling. I'm going to bounce back over here to my textbook, and it says click here to view Exhibit 1 or Exhibit 2. So I've already pulled those up. Exhibit 2 was the present value of annuity. Exhibit 1 was the present value of $1. And the way I have this set up, we're actually calculating the present value of 5 independent cash flows. So, and we're gonna bring each of those back one at a time to present value. There are other methods to do that, and since we have cash flows that are the same amount each year, you could actually use this one, but you'd have to set up the problem a little bit different. The textbook recommends using the present value of $1, and that is simply because typically you don't have cash flows that are going to be the same every year, and you might have some cash flows in the end for a salvage value of whatever your investment was, if it was equipment, that may be different. So usually those cash flows will go up and down over the course of the year. So the textbook actually recommends to use this chart. So this is the way I set it up, and this is what we're going to use. So we've got to find the discount factor for each of the time periods that we're looking at. So let's look at year 1. So when we look at our periods of time, we're going to go down to the period of 1. And I forgot what the percentage was we're looking at, so let's go back over here. So the question said that the discount rate for the company was 18%. So we're going to go over to the 18% column and go down to the 1 period because we're at the first year. And the discount factor for that is 0.847. So we're going to go back to my chart and put in the discount factor of 0.847 for year 1. For year 2, same thing, still have a discount factor, or have a percentage of 18%, but we're going to go down to the second line, which is at the 2-year period. So that one is 0.718. Year 3, still under 18%. That one's 0.609. Excuse me. Year 4, where are you? Year 4, 18, looks like 0.516. And year 5, still under 18%, looks like 0.437. All right. So at that point, after we figure out what the discount factors are, we're simply going to take each of these cash flows and multiply them by the discount factor. So when we look at year 1, the present value of $90,000, if we were to get that $90,000 in 1 year and then discount it back to the present value of that $90,000, it's $76,230. So like I said, we should expect those to be lower because we're discounting them back to the current period, because as time passes, the $76,230 that we might have today could earn interest, and it would grow over the course of a year and eventually would be worth more, in this case $90,000. So you're going to do that for each of these, and I'm going to be lazy and drag those over so it just copies my calculations. And after we do that, we need to figure out the net present value of the entire product. So to do that, it's just the total of all of these cash flows. So you have an initial cash outflow, and then you have 5 cash inflows. So we're going to total those. So our net present value for product A is $21,430. So we're going to do exactly the same thing for product B. So let's see if I can get these side by side again. Enough so we can see them. Let me move this over a tad. All right, so our purchase of equipment for product B is $470,000, and that's a cash outflow. And then it looks like we're going to jump over here, and our sales were $410,000. Our variable expenses were $194,000. And our out-of-pocket costs were $56,000. So those are our cash flows for the year, for year one. Let me get over here to my sum button. Okay, so that gives us a cash flow for year one of $160,000. And again, there's no fluctuations in those numbers, so we can copy those over. And in year one, the cash flow was just the outflow of in the now period, it's an initial cash outflow of $470,000. So I'm going to move this back over. So again, we're looking at the discount factor. We're covering the same period of time, so we have a now period and then years 1, 2, 3, 4, 5. We're talking about the same company, so we're going to use that same percentage of 18%. So these are all going to be the same because we still have the same periods of time and the same percent. So whoops, I don't want to paste, I want to copy. So I'm just going to copy those and paste them down here. Save a little time. And then we're going to calculate our present value. So our present value, remember, is our cash flow times our discount factor. And so this first one's going to be exactly the amount that we paid out because it's happening today. And then each of these other ones we should expect to be lower than $160,000. And they are, and you'll notice that the further out in time we go, the lower those amounts get because we're discounting them backwards over a longer period of time. So again, calculating our net present value, we're going to sum the present value of all of those cash flows. It gives us a net present value of $30,320. We're going to interpret that a little later when we decide how we're going to make a decision, but for now we're going to move on to requirement 3. It says calculate the internal rate of return for each product. So we've got product A and product B, and again I put the formula here, so this is the formula that we're going to use. So for this one, for product A, our internal rate of return would be the investment required, which was $260,000. We're going to divide that by the annual cash flow. And that annual cash flow is $90,000. And hold on just a second, and I'll show you where I got that. So that's this line that's total cash flows, $90,000. That was the denominator that I used in this case. So our internal rate of return for product A is 2.88888, or if you want to round it, 2.889, if you want to do it that way. So then for product B, we're going to take our initial investment, which was $470,000. And the annual cash flow from that one was $160,000, same place, only I'm looking in the product B chart. So here's our total cash flows, and it's $160,000. So our product B factor for the internal rate of return was 2.938. So that's step, and I actually should probably put step 1. So that's step 1. So step 1 gives us some numbers, and we've got to then go to our charts and try to figure out how to find those. So jump back over here. So we're going to use chart 8B2, which is the present value of an annuity of $1 in arrears. And that's because when we're looking at the internal rate of return, we're essentially working with a series of equal cash flows. So when we did our calculation, we were looking at an initial investment and we were dividing that by an annual cash flow, which we are assuming is the same every year. So we're going to use that annuity chart, which has to do with equal payments over some period of time. So we're going to use chart 2, and it says for product A, our factor was 2.888888 or 2.889 if you want to look at it that way. So we're going to jump back over here, and we are looking for a project that lasts 5 years. So we're going to be working with this line that is a 5-year line. The problem is we don't know this part. So in the last example, we used the other chart, but we had a period of time and we had a percentage that we can read across and down and figure out what the factor was. In this case, we have a period, but no percentage, but those numbers that we just calculated are actually the factors that we're going to use. So we're going to look for something that's close to 2.888889 in this line number 5. So we're going to read across. So we've got at 22%, 2.864, which is less than our number, and at 21%, 2.926. Which is more than our number. So it's somewhere between 21 and 22%. We're not interested in splitting frog hairs here, so we're not going to calculate it exactly. So since it's between the two, we're just going to call it 21.5%. So over here, our internal rate of return is 21.5% for product A. We're going to do exactly the same thing for product B, except we're going to use that number 2.9375. So same chart. We're still working with the 5-year period of time. And we're going to read over until we find something that's close to 2.93, about 2.938. So again, we've got something that's between 2.926 and 2.991. That's 21% and 20%. So it's somewhere between there. You could say if it's closer to the 20%, you could call it 20% or 20.5% if you want to call it as in between there. So I would take either one of those if your problem comes up between, if you call it with the one that it's closer to, or if you want to split it in half and do 20.5. This one's actually closer, so we're going to call it 20% for product B. All right, so that's the internal rate of return for each product. The next thing we're going to do is calculate the project profitability index for each product. So we do this, and this is actually the formula. Project profitability index equals our net present value divided by the investment required. This calculation considers constrained resources. In other words, we're looking at that initial investment, because cash, if we're investing cash, cash is a constrained resource. No one has an infinite amount of cash, so we have to work with what we have. So this particular index is going to look at that constrained resource as the denominator. So our net present value for product A our net present value for product A, and I'm actually in requirement 2, which is where we calculated the net present value. So there's our net present value for product A was $21,430. So let's go back down here. Whoops. and that's going to be divided by the investment. And for product A, we had an initial investment of $260,000. This gives us a project profitability index of about 0.08. So you can round that if you want to. For product B, again, we're going to look at the net present value. So we're going to go up here to requirement 2, I think it was, to our chart for product B. The net present value was $30,320. So we're going to jump back down here. Sorry for all the scrolling. I need a really huge laptop, I guess. So I don't have to do that. Okay, so $30,320. And we're going to divide that by $470,000, which was the amount that we initially paid out. It gives us a project profitability of index of about 0.06. So that's all there is to requirement 4. Requirement 5, calculate the simple rate of return. We're going to look at the annual incremental net operating income divided by the initial investment. I think I didn't leave enough lines here, so we'll probably have to add some. So our annual incremental net operating income was all the way back up here. You can get it from step 1 in requirement 1, which was the $90,000 for product A and $160,000 for product B. Or if you want to stick with using the requirement 2 chart, we had the same numbers in that one, in that line there that says total cash flows, and that the annual incremental net operating income, what a mouthful, that is the $90,000 and the $160,000 for here for product B. So let's go back down here. Oops, and I'm telling you wrong. So let me figure out the best way to show this. You can do this out over to the side. Sorry, I missed setting that up whenever I set up my spreadsheet. So, okay, now our annual net cash flow, which I was looking at just a second ago, from either of those charts, was $90,000 for A and $160,000 for B. Let me just label these out to the side so you know what I'm doing. This one actually also considers the depreciation expense, and that's what the step I was missing. So our depreciation expense, we haven't used up to this point, so you actually have to go back to the instructions, if I can find them in the right tab. So here's our depreciation expense for product A and product B. It's $52,000 for A and $94,000 for B. So now we have our annual incremental net operating income, which would be the annual net cash inflow less that depreciation expense. So let's see, let me mark that. All right, so now we can do our calculation now that we've calculated an annual net operating income. So for product A, our annual net operating income is $38,000 divided by our initial investment of $260,000. There we go. So if you wanted to change that over into a percentage, it's about 14.6%. Let me just put that here. So since we've been talking about percentages. And our annual net operating income for B was $66,000 divided by that initial investment of $470,000, which is 14.0%. If we want to round that to one place. Well, actually I rounded to 2, but so this is actually the answer to the question. The simple rate of return for product A is 14.6%, and for product B is 14.4%. Phew. So now let me fix, that's bugging me. It's the accountant in me coming out. I need some formatting here. All right, so now it's pretty. Okay, so for requirement 6, I said for each measure, identify whether product A or product B is preferred. And we've got the net present value, profitability index, payback period, or internal rate of return. So if we're going to do that, we're going to have to scroll back up to our work we did earlier. And I didn't put the payback period. I guess I probably should have, but let's just look at that one for a minute. So we're looking just at payback period. Then product A is going to be preferable because it takes a shorter period of time for us to really make our money back or to recover that initial investment. So for payback period, we'd want product A. For net present value, we're looking at the present value that is the greatest, because we want something that's worth the most at the current period of time. So we look at product A is about 21,000, B is about 30,000. So for net present value, product B is preferable. So let's go down here and note that. Let's look at profitability index. So where was that? There it is. So that was requirement 4. Profitability index for product A is 0.082, blah, blah, blah. Profitability index for B is 0.0645, blah, blah, blah. So the rule of thumb for project profitability index is the higher one's the better one. And that's because we're looking at constrained resources. So we want something that that is the highest of the two. So that would be product A. So we're looking just at product profitability, product A. Oh, there's my payback period. I just had them out of order. So we already said that one was product A. Did I get that right? Let me make sure. Not that I already forgotten. Yeah. Payback period A is shorter than B, so that is better. And what else is it asking us? Oh, internal rate of return. So our internal rate of return is 21.5% or 20%. So we're looking for something with a higher rate of return. So we, again, are at product A for this indicator. So this says, which of the two products should the division pursue and why? Well, it depends on which method they're going to look at. If we look at the profitability index, the payback period, and internal rate of return, those all indicate that we should pursue product A. The net present value method says that we should pursue product B. So it depends on which one you're looking at. We could, and this one I didn't ask this one, but if we look at our simple rate of return was 14.6 and 14.0. Those are both lower, and let me look at the book again so you can see what I'm looking at. So the simple rate of return are both around 14%. This says that Lou's raises are based on his division's return on investments, which has exceeded 20% each year. In other words, historically, the company has had a return or has earned 20% on their investments on whatever, and I don't know what those investments were, but however they invested their money, they have typically earned at least 20% on those investments. So in our work, when we're looking at product A and product B, we have the option of investing some initial investment into one of those two products and earning some money back. But if we look at the simple rate of return, which is the last thing we did, which is about 14%, they're going to earn about 14% simple rate of return on that investment. The other alternative is to take those initial investments and invest it in what they typically invest in, which is what they're earning 20% on. So they may decide to do neither of these and simply take the money that they were going to invest in either product A or product B and invest it in whatever they usually invest in. So I'm going to type that just so you can see this on the video. So which should the products, which should they pursue and why? Well, the answer is it depends. So it depends on the method they use to assess the value of each product, and we see that up here in requirement 6A. Different methods yield different results. And you could argue that, well, 3 of them lean towards A and 1 towards B, so maybe you want to pick A because of that, or maybe you're more interested in what's going to have the greatest net present value. So it just really depends on what the philosophy or the policy of management is and how they value those investments and what they typically use to value those investments as part of their business decision-making process. So my answer is going to be it depends. Depends on what method they say they want to use. And then we could also argue that they may choose to do neither. And that is because the simple rate of return on each of these products is around 14%. And the company could earn about 20% on typical investments that they make. Sorry, it's hard to write and type at the same time. So that's just another way to look at it. It's probably a good way to look at it, unless they're just really aching to invest in one of those products and maybe looking more in the long term of, you know, we might be able to earn 20% on that money in the next 5 years, but over the long term, can we grow product A or product B into, I don't know, a full division or a really profitable part of what we do over the long term? So that may be something that they're going to look at. So they may be willing to do that just because they can see out into the long term where we don't have enough information to really make that call. So requirement B, you can kind of see what I did. Your answers may be different because I looked at requirement 6A just to answer 6B, but my 6A answers were dependent on the numbers I used. So yours may be different, but just kind of as a rule of thumb, your net present value, you want the product with the biggest present value. With profitability index, you want the one with the highest profitability index. With payback period, you want the one with the shortest payback period. In other words, you want to make back your money as quickly as possible. And then in your internal rate of return, you want that to be the highest rate of return. So those are just kind of what you're going to look at. And then we did with the simple rate of return, I compared that to what they typically earn on their investments. So I hope this was helpful. You don't have to use my templates, but you can if you want to. I've kind of got them set up, so that might be a little bit helpful. The main thing is to make sure you use the right chart. And for those charts, you have to. There's 3 pieces of information. You need to read them. It doesn't matter which either chart you use. You have to know the periods, or the percentage rate, or the discount factor. So if you know any 2 of those, you can back into the 3rd one. So that kind of helps you to know how to read those charts. Then do it that way. So have a great week, and I will talk to you again next week.